Think math.
2, 3, 5, 7, 11, 13. Numbers divisible only by 1 and themselves, the primes. But as numbers grow, primes get rarer and rarer. So maybe, at some point, there is a last one? Do the primes ever end? Suppose they do end. Once again, this is proof by contradiction. Say every prime in existence is right here. 2 times 3 times 5, all the way up to a last prime, Pn. This finite list holds every prime there is. Now multiply all of them together and add just one. Call this number n. So n is exactly one more than the product of every prime on our list. Divide n by each prime on the list. By 2, the product already contains a 2, so it divides evenly, and the extra one is left over as a remainder. By 3, remainder 1. By 5, remainder 1. Divided by any prime on the list, n always leaves a remainder of 1. So no prime on the list divides n. That means n is either a new prime itself, or it is divisible by some prime that is not on the list. Either way, there is a prime outside our list, which contradicts the claim that the list held them all. No matter how many primes you gather, multiply them and add 1, and a brand new prime appears outside the list, so the primes never end. There are infinitely many. A slice of math every day here at Think Math.